Hi, in this video I'm going to show off the procedural texturing module for MicroSplat. With this module you can texture your terrain entirely procedurally based on height, slope, cavity data, and erosion data. This can all be generated in the editor. The data for cavity and erosion and everything else can happen in real time on your terrain, requiring no splat maps or external data. So as an example here, I have a terrain. You'll notice that the splat map resolution is set to 16 because we won't be using splat maps in this tutorial. There are also several features that can be applied to splat map based terrains, which I will cover as well. So this terrain has already been set up with MicroSplat, and we're going to go ahead and open the material now and add the procedural texturing feature. So when we turn this on, presented with several new options. We can use what's called a biome mask to have a texture associated with this terrain that lets us determine 4 different biomes. So we could have desert, we could have grasslands, forest, and hills, or something like that. And we could use an RGBA texture to specify that by setting it to splat map mode. In exclusion mode, we can actually have 16 biomes with some restrictions. So what happens in this mode is that pure colors like yellow 1, 0, 0, they actually act as their own biomes. So with that, you can get 16 combinations of biomes, but you won't get blending. You'll only get the yellow biome where it's exactly yellow. Next up is noise space. So the procedural texturing module allows you to induce noise into various functions, and this will control what space the noise is in. Your choices are UV, which will use the original UVs of the terrain, world, and triplanar. The reason to use world as its default is that if you have multiple terrains, this means that the noise will be continuous across the terrains. With UV mode, each one would have its own space for the terrain based on the UVs. And with triplanar mode, it's going to be in world space, but projected in triplanar, which can help fix some stretching of the noise on slopes. The next 2 options are cavity map and erosion map, which I'll be covering later. When these are turned on, you have the option to generate your own cavity and erosion map, or you can use one from an external program if you're using something like Mudbox to texture your terrain. We've enabled procedural texturing, and so we get the new procedural texture section here in the editor. And here we can provide a noise texture. There's one automatically applied. That is what we're going to use for the noise. And then there is a height range for the world, which we need to specify, and this is the minimum and maximum size of our world for height-based operations. And then there are what's called layers. And you can have up to 32 different layers, and you can basically, each layer is a procedural texturing rule set which will apply a texture. So let's just set this to 1 layer, and what we have here is 1 layer which is going to apply this texture. If I change which texture is getting applied, you'll see that the terrain updates instantly with that texture. This is because it's all being done in the shader. There is no processing involved. We're just changing an index. So this rule is going to apply this particular texture. Now, because we only have 1 rule, we're only going to get 1 texture on the terrain. So let's add another rule. And the way the layers work is very similar to Photoshop layers, where this is the highest layer and has preference in opacity over the lower layer. So this is like a background layer now. And so what we're going to do is we're going to set the background layer to be grass. And then we're going to blend in another texture based on some of these rules. Now we can use a weight here to adjust these. So I can lower the weight. You can see it's just blending in the texture into the previous one. But that's kind of not that interesting because we're just blending the same thing across the terrain. So what we really want to do is modify the weight based on some of these parameters. For instance, I can modify it based on height. And when I turn this on, we can see that the lower parts of the terrain are getting this texture with higher weight, and the higher parts are getting less. And there's a curve here to specify that. And you can specify whatever curve you want. The way that all these curves work is that the y-axis here is the weight. And then the axis on x is the value comparison. So in this case, these are the low areas on this side, and these are the high areas. And so we're weighting the low areas with high weight and the high areas of the terrain with low weight. And you can see, as I adjust this curve, everything will adjust in real time, which is very nice. So we can determine an area that we want this texture to exist at, and at what weight it should exist. And there we go. And now what we can do is we can add another control. So in this case, I'm going to use slope. So slope works basically the same way, which is that this is the amount of weighting and this is the amount of slope. So a slope value which is low is going to be flat, and a slope value which is high is going to be steep. And so you can see I can remove or add more to the slopes here by adjusting the slope control and determining where I would like that texture to exist. And if I was to invert this, you can see that it only exists on the slopes, except the height is filtering it, unfortunately, because that's where our slopes happen to be. And then finally, there is a noise function, and this uses noise to inject some variation in what you're seeing. And this is really where things get fun. So if we turn on the noise, we have our standard noise controls of the frequency of the noise, which is how the scale of the noise, essentially, from that texture. The offset of the noise, which is just positioning it. So if I change this back to 0, so if you have some very similar noise values, you may offset them between multiple layers. And then there's a min and max scaler. Okay, so this controls the values that the noise is going to apply. And in this case, you'll notice we have a negative minimum value. So it will actually cut out of the terrain in some areas, and our max is very high. If we change that to be something more reasonable, you'll see that the noise affects things less. As we push down in negative scales, you can see that we cut away more of this texture. So you can use this to sort of add or subtract texture into your filtered area. And when you go above 1, you're basically boosting the value around the edges of where the weight is not quite 1. So we can adjust that until we like it and continue to add layers to this process. And you kind of always want the last layer to just take whatever weight is left. So in this case, if we want to add another layer, what we really want to do is insert that layer before this. Sorry, my insert control would happen here. So we insert this layer after this one. So now we have another layer. Again, we can use the same texture in multiple layers. So if we want to apply those rocks somewhere else with some other rules, we can do that. And in this case, I actually it inserted before, so I'm going to move this layer up. This is the one we last worked on, so that this one happens first, and then this one is kind of acting like our new background layer because we haven't set up any filters yet. But then we can set up a slope filter on this. And let's make this only appear on high slopes. I need to pull this down. Actually, do this. So here we see we're getting it just on these slopes here by setting that curve up to only use the slope values here. And we can kind of soften that a little bit, get a little bit more of it in there. There we go. And maybe we want to height filter this as well so that we don't have this appear on tiny slopes in the bottom of the terrain. And we can play with these values until we get, there we go. You see the effect. So now we know it won't appear if we had little slopes on the bottom. And again, this is all dynamic, so if I come in here and I start painting the height of the terrain, then it's all going to update real time with whatever we're doing on the terrain here. So as I pull up this terrain, if I pull it up high enough, you'll see that those rocks go away, and we'll start getting the slope texture on here. If we can get high enough. Undo. Okay, good. Undo is working. But yeah, if I go and I change any of this stuff, you can see the texturing is just coming along with it and deciding what it's going to do according to those rules. Undo that. And you'll notice, if you're familiar with the normal data controls for procedural normals, or sorry, not procedural, for pre-calculated normals for your normal map. If you're on Unity 2018.3 or later and using instancing, this is automatic. It's provided by Unity, but if you're on previous versions or not using instancing, then this normal per pixel normal data is how the terrain can get its normal on a per pixel basis instead of per vertex, which looks better. And you update these. So whenever the terrain changes, it will let you know it needs updating. This is basically the cavity map feature, which we're going to talk about next, has the same basic controls, which is that I can update or clear this map. Now the difference is that I can also provide my own map here if I've taken this cavity data from another program. So let's get back to our material here, and we'll enable that feature. Turn on cavity map, and we're going to go ahead and turn on erosion as well. So a cavity map is kind of like an AO map. It's showing you where little creased areas and things are in the terrain. And then there's also the erosion map, and what the erosion map gives you is where water would flow if you were using water. If you had poured water over the terrain, sorry. So this layer has erosion and cavity filters, erosion filters on it. So I'm going to turn that off. That was from when I was working before. So that's why the terrain changed. So let's go ahead and add another layer, and we will play with that. And what I'm going to do is I'm going to go ahead and insert that layer in the first one so we can just see how that is affecting things versus the original terrain. And let's give it a different texture for now. Let's say we'll use this texture that we haven't used. So we can see the previous terrain coming through as we adjust for cavity. So if I pull this control down, and let me tighten it up so we can see a really clear transition. I'm going to go on the other side here. So here we have our cavity map showing us kind of where the creases are in this terrain. And if you're enabling this for the first time, you actually have to compute the cavity map. And the way you do that, just in case it wasn't clear before, is you come onto your terrain, and then in this section here where the cavity data is, there's a generate button. If I clear this, you'll see that I have a generate button. I can hit generate, and that will actually generate this cavity and erosion map for me, or I can provide external data from a program. The way this map is packed, let me go ahead and open this in Photoshop. Open Photoshop. So in Photoshop, Photoshop does this. I hate the way it handles alpha. But basically, the alpha channel is the flow map, which you can see is cutting away this green. And the green channel would be the cavity map. Unfortunately, the way that Photoshop handles PNG files in alpha makes it hard to see this. But if you pack in any texture, you pack a cavity map into the green channel, and your flow or any map you want, or erosion map, into the A channel, then that will correspond to the cavity and flow controls here. And if you want to use those for something else, you could paint arbitrary masks there or whatever you want. They don't have to actually be cavity or flow, but that is what my generator will generate in those values. So you can see that we've managed to put this little bit of texture into the cavity here using the cavity controls on this top layer. And again, as we adjust those, you're going to get more or less of that until it sort of leaks out over everywhere where there's no cavity. Cavity is centered around 0.5. So effectively, if you're going below there, you're getting increases. If you go above 0.5, you're getting in the non-cavity areas, basically the open areas of the terrain. So generally, you're going to want that centered somewhere around 0.5 and probably be going lower than it to get the cavity map to do what you expect. So the erosion map, this is also called a flow map in some of these tools. This is where water would go when it's raining, essentially. And again, it's centered around 0.5. So we can come in here and adjust our controls around the center. And as we widen them up, you can see the flow lines up here of where water would flow down this terrain. Like that. So if that's useful to you, then you can generate these types of flow lines and use them to texture your terrain. So that's basically this procedural texturing system. Remember to set the world height range to something that makes sense for you. And we're going to go down and discuss two new per texture controls that are added by this module that you can use to texture either your procedural terrain or your regular terrain. And the first one is called gradient tint, height gradient tint. And what this is over that height range that you specified in the procedural texturing section, we can specify a tint for our textures. So in this case, I'm tinting the grass to be kind of ridiculously green at the bottom and not as green at the top and darker. And you can adjust all of this in real time and get a tint over your terrain. And so that's pretty cool because you can really change the look of things with that. But there is also another control here for HSV adjustments, so hue, saturation, and brightness essentially. The actual code uses, if you're familiar with HSL and HSV and HSB color spaces, the actual internal color spacing I'm using is HSV, which is value instead of brightness, but I call it brightness here because that's how people tend to understand it. And so when I turn on these controls, I get curve controls now for the hue, saturation, and brightness of each texture. And in my previously, I was playing around with this and had set this up, and you can see on the grass texture what I'm doing is adjusting the hue so that we get kind of green grass at the bottom and brown grass at the top. And I'm doing the same thing with saturation and brightness just to tweak those ever so slightly so you get these different hues of grass over your terrain. And these are full curves. They are, you can see here, I'm adjusting the hue of this. And then here is the saturation controls. And so again, if I'm desaturating it as I go down, if I were to desaturate the bottom of the terrain, you can see all of this happens in real time. And we get the desaturated down at the bottom here. Bring this up. Saturation back to 0. And yeah, so that allows for new types of texturing. And again, this works on regular splat map terrains as an adjustment. So I put it in the procedural module because of, for one, it gave me a nice place to store the data, and two, it just felt like a procedural sort of thing, even though it works on normal splat maps. So that's basically what this module adds. Let me see if there's anything else I need to talk about. We covered the noise space. So the noise space, when you put it in triplanar, is just going to triplanar texture the noise. There are cases where that may become useful for people who have very large terrains. I was using it for planet-side rendering. But yeah, you can see how powerful this can be as I sort of have tinted these stones a little bit red here as we get up to the top of the terrain, yet they're gray down here. I did that with the HSV settings. And so that can give you a really nice overall look over your terrain, sort of a post-processing over the terrain to give it more detail about its height and slope and things. So yeah, I hope this has explained everything, and if not, you can always read the docs. They're usually pretty comprehensive, and thanks for watching.